Betelgeuse, like any star, will eventually run out of fuel in its core, leading to significant changes. As it depletes its fuel, it will begin to expand, potentially engulfing the orbits of Mercury and Venus and coming dangerously close to Earth. This process marks the star's transition into the final stages of its life cycle, and it is a phenomenon that astronomers have been closely monitoring. The star, often referred to as Betelgeuse, is approaching its end, and the news has been a tough pill for scientists to swallow. There is nothing they can do to stop the impending supernova. Astronomers have speculated that this could happen tomorrow, next month, or within a few months, but the exact timing remains uncertain. One thing is certain, though: Betelgeuse is dying, and its death will have significant implications. The imminent explosion of Betelgeuse into a supernova is a topic of great interest and concern among scientists and the general public alike. This event is noteworthy not only because of the star's prominence but also because of the potential effects on our planet and the broader universe. If Betelgeuse were to explode today, as many scientists predict, the results could be transformative. In this exploration, we will delve into what makes the Betelgeuse supernova so special and why it has captured the world's attention. Recently, NASA's chief announced that Betelgeuse is set to explode in 2024. This announcement has heightened global awareness and concern about the oncoming supernova. The NASA chief's emotional warning underscored the gravity of the situation, suggesting that the explosion could alter the trajectory of our planet and life as we know it. Betelgeuse, often likened to a terminally ill patient, is drawing ever closer to its inevitable end. Its death will mark the end of an era in the night sky. For decades, astronomers have been fascinated by Betelgeuse, spending considerable time studying its features and the impending explosion. This red supergiant star has been one of the most remarkable objects in the Milky Way, captivating astronomers and stargazers alike for centuries. Betelgeuse is known for its variability in brightness, with its apparent magnitude ranging between 0.3 and 1.6. This variability has been noted since ancient times, with classical astronomers like Ptolemy describing the star as more or less orange. Ptolemy, an Alexandrian mathematician, astrologer, astronomer, and geographer, spent years studying Betelgeuse, providing early descriptions of this giant star. Even Aboriginal groups in South Australia have shared oral tales of Betelgeuse's variable brightness for at least 1,000 years. Modern advancements in astronomy have given scientists a more accurate picture of Betelgeuse and its characteristics. Found in the constellation of Orion, Betelgeuse is one of the largest stars in the universe. Red supergiant stars like Betelgeuse are some of the most massive and largest stars, with diameters ranging from 100 million to 1 billion kilometers. If Betelgeuse were placed next to our Sun, it would be 100 to 1,000 times wider. A red supergiant star, like Betelgeuse, is formed when a massive star exhausts its fuel. Unlike red giant stars, which form when a star with the mass of our Sun runs out of fuel, red supergiants arise from stars with more than 10 solar masses. As these massive stars exhaust their fuel, they can no longer generate the heat and pressure needed to support their immense weight, leading to a collapse. Betelgeuse's brightness is another notable characteristic, making it the 10th brightest star in the night sky and the second brightest in its constellation, following Rigel. If we could observe the night sky at near-infrared wavelengths, Betelgeuse would be the brightest star. Its radius is 640 times that of the Sun, and if placed at the center of our solar system, Betelgeuse's surface would extend beyond the asteroid belt, engulfing the orbits of Mercury, Venus, Earth, and Mars. Scientists estimate Betelgeuse's mass to be between 10 and 20 times that of the Sun. Interestingly, Betelgeuse is only about 600 light-years away from the Sun, which is relatively close in cosmic terms. Despite its proximity, astronomers were surprised to learn that Betelgeuse is less than 10 million years old, a young star compared to our Sun, which is about 5 billion years old. However, Betelgeuse's size compensates for its youth, overshadowing most other stars in the universe. Determining the precise diameter of Betelgeuse has been challenging for scientists because it is a pulsating star, meaning its diameter changes over time. This pulsation, combined with other factors, has made it difficult to obtain exact measurements. Nonetheless, Betelgeuse remains one of the most studied stars, and its impending supernova is one of the most anticipated events in astronomy. As we continue to observe and study Betelgeuse, we prepare for the day when it will no longer shine, forever changing our view of the night sky and our understanding of stellar life cycles. Betelgeuse, one of the most studied stars in the night sky, presents a unique challenge to astronomers due to its lack of a definable edge. This difficulty arises from a phenomenon known as limb darkening, which causes the star's optical emissions to vary in color and decrease the farther one moves from its center. Compounding this issue, Betelgeuse is surrounded by a circumstellar envelope composed of matter ejected from the star, making it difficult to precisely define its photosphere. Additionally, the star's apparent size changes depending on the wavelength used to observe it. Atmospheric twinkling, caused by turbulence in Earth's atmosphere, further limits the resolution obtainable from ground-based telescopes, adding to the complexity of accurately determining Betelgeuse's diameter. Despite these challenges, scientists have managed to estimate the diameter of this gigantic star. Betelgeuse's extended atmosphere adds another layer of complexity to its study, presenting puzzles regarding the dynamics of mass loss. It is known that the mass making up galaxies is recycled as stars form and are destroyed, but the precise mechanisms of mass loss remain elusive. This mystery, while intriguing, pales in comparison to the latest findings about Betelgeuse's rapid evolution due to its large mass. This mass has caused Betelgeuse to evolve much faster than many other stars, providing a direct correlation between its mass and its evolutionary pace over millions of years. One of the most dramatic developments in the study of Betelgeuse is the realization that it is approaching the end of its life. The red giant star is expected to conclude its evolution with a supernova explosion, which could occur at any time. This impending supernova has put the scientific community on high alert. A supernova is a powerful and luminous explosion that occurs during the last evolutionary stages of a massive star or when a white dwarf is triggered into runaway nuclear fusion. This explosion results in the collapse of the original star into a neutron star or black hole, or its complete destruction, forming a diffuse nebula. If Betelgeuse were to explode today, its peak optical luminosity could rival that of an entire galaxy before fading over several weeks or months. This spectacular event would be visible to the naked eye and could be either a source of excitement or fear for viewers. Despite its impending doom, Betelgeuse remains a familiar object in the night sky, visible to the naked eye for much of the year. However, it becomes almost unobservable from the ground between May and August due to its proximity to the Sun. This periodic invisibility is one of the many mysteries surrounding Betelgeuse. Betelgeuse is also notable for its position in the winter triangle asterism and its role in the winter hexagon. From early January, it rises in the east just after sunset and remains visible until mid-March to mid-September, observable from almost every inhabited region of the world except Antarctica. On any given night, once darkness falls, Betelgeuse can be spotted among the array of stars adorning the sky. If it were to explode, the supernova would be visible to everyone, casting a bright point of light that could potentially illuminate the night as brightly as the half-moon for more than 3 months. Betelgeuse is located approximately 642 light-years away from Earth, making it relatively close in cosmic terms. This proximity means that the effects of its supernova would be keenly felt on Earth. The explosion would be a dramatic event, potentially casting shadows at night and altering our view of the night sky. Betelgeuse is a pulsating semi-regular variable star, meaning its brightness varies due to changes in its temperature and size. This variability has long fascinated astronomers and has made studying the star both challenging and rewarding. The first time astronomers observed Betelgeuse's variability, they were amazed by how its brightness could change dramatically in a matter of days or months. This characteristic has been a significant challenge for astronomers, making it difficult to obtain accurate measurements of the star's brightness. Despite these challenges, Betelgeuse remains one of the most studied and fascinating stars in our galaxy, continually providing new insights and surprises for the scientific community. In summary, Betelgeuse's lack of a definable edge, circumstellar envelope, and variable size and brightness present significant challenges for astronomers. Its impending supernova is a dramatic event that has captured the attention of scientists and the public alike. As Betelgeuse approaches the end of its life, its study provides valuable insights into the life cycles of stars and the dynamics of mass loss in the universe. The eventual explosion of Betelgeuse will be a momentous event, visible to the naked eye and altering our understanding of the cosmos. Until that day, Betelgeuse continues to shine brightly in the night sky, a constant reminder of the dynamic and ever-changing nature of the universe.